Chapter 1 is all about the characteristics of life and scientific thinking. Let's say you run across an advertisement that looks something like this. When you see something like this, some of you might look at that and say, oh, I wish I could get my hands on this stuff. That'd be great. Others might look at that advertisement very skeptically and say, wait. That can't be true. It just doesn't make sense. 25 pounds in 2 weeks is a lot of weight. And you might have some questions. Whenever you see something like this, you should ask some questions. For example, you should ask, is the information consistent with other sources? In other words, it doesn't make sense that someone could lose 25 pounds in 2 weeks. Does that information seem consistent with other weight loss programs? You might ask, how reliable is the source? In other words, who did all the testing? Did the company who produced this wonder nutrient also do the testing of the wonder nutrient? Because they have a bias. They have a point of view that they're trying to support. In this case, they want to make lots of money. So they have a vested interest in their test results being good. So you might ask, like, how reliable is that information? Like, where's that information coming from? Can I trust it? Another question is, did they use proper scientific procedures? In other words, when they designed their experiment, how scientifically did they go about doing that experiment? As you can see here, the one person that they have advertised, Kathleen Hodgins, has lost 25 pounds. And they do admit that those results aren't typical. They do also say that some people lose 10, 25, or 50 pounds. We don't even know if the picture of that person is Kathleen Hodgins. So there's a lot of things that we might wonder about. We see that there's a lot of variety in the results. So just how scientifically did they go about designing that experiment? And what kind of process did they use to come up with those conclusions? Then we might ask, did they interpret the results correctly? That is, when they saw the results, did what they see match up with what they were hoping to see? Or, did they analyze it? Did they use some statistical analysis at all? Did they do that analysis correctly? So sometimes, we hear results and it can be very misleading. Or sometimes the results are displayed in a very misleading way. So for example, you might see a bar graph where you have this big tall graph and you have a smaller one. And at first glance, it looks like this smaller one is half the size of that tall one. But really the data is just the difference between maybe 1 and 2. Like if this is 2 and this is 1, which, just that little bit doesn't make a huge difference. So it just kind of depends. Like, did they interpret those results? Are they displaying them accurately or helpfully? And then finally, we might ask, are there any other possible explanations? Was there anything other than this wonder nutrient that, like exercise, or maybe age, or maybe gender, or maybe body type, or some other genetic thing? So is there any other possible explanation that could have influenced these results? So those are things that when you're designing an experiment, you want to consider. Like, how could I eliminate some of those things? How can I eliminate bias, for example? How can I eliminate other possible explanations for it? How can I make sure I'm interpreting the results correctly? So when you're designing a scientific experiment, think about those things. A scientific experiment starts with an observation. So those observations are based on the 5 senses, or maybe some tool that we could use to help augment those 5 senses. And then once we make that observation, we come up with some kind of hypothesis, a testable statement. And we normally use deductive reasoning. Now, deductive reasoning is this idea that we start with a conclusion and then we see if the evidence supports it. Inductive reasoning is the opposite. All right, so inductive reasoning, we first look at the evidence and then we see what conclusions we can draw from the evidence. Think of it kind of like stealing cookies. Deductive reasoning would say Jane stole the cookies. Now I need to see if the evidence fits that conclusion, that statement. If the evidence doesn't fit, then I disregard it and I say Mark stole the cookies. Inductive reasoning is the opposite. Inductive reasoning would say who stole the cookies, and then we start to look for the evidence. There's crumbs around the jar. There's footprints in the room. We measure the footprints, we look at the crumbs, we see if we can find crumbs on someone's clothing, and based on that, we make the conclusion Mark stole the cookies. Once we have our hypothesis, we can start to design our experiment. In our experiment, we want to make sure we have some kind of control group. That is something, a group where we don't expect anything strange to happen. And then we have some variables where we might increase the amount of something, or we might change the rate or the conditions of something, but we introduce some variables to test to see how do the variables, how are they different than our control, which we didn't expect anything would happen to our control. When we get that information, we can analyze that data and then draw some conclusion from it. And when we analyze that data, what it might indicate is something was wrong with our experiment. We have to go back and fix it. Or maybe something's wrong with our hypothesis. We have to go back and say, no, it wasn't Jane. Let's try Mark. And then we test to see if it's true. Going back to this wonder nutrient or this wonder drug, we might make the observation, oh, people who take this wonder drug, it helps with their weight loss. So we come up with a hypothesis. Notice in my example hypothesis here, that wonder drug is related to weight loss. And if that's the case, we would expect to see more drug, more weight loss. So the more they take this stuff, we would expect to see better results. When we set this experiment up, we need a control group. So a group that's just taking a placebo. So they might take a sugar pill or something like that. So it looks like the wonder nutrient, but it's not. All right, so that's our control group. And then we're going to set up some variables, things that we might change. So we might change the population dynamics. We might change the amount of nutrient we give. So in this case, we're going to give one group of people the placebo, the next group of people just 1 gram, third group of people are going to get 10 grams, and the last group is going to get 100 grams. And then over the course of a week, we're going to take that data. Then another week, we'll take that data. And maybe 3 weeks, we'll take that data. And we want to see, is there significant weight changes in the average population of each of those groups based on the amount of this wonder nutrient they're taking. If we are trying to get this wonder nutrient to market, now one of the difficulties in the United States, of course, is that so long as we're just advertising this as a supplement, there's no FDA regulation. We can make whatever claims we want about it. But if we want some FDA approval, then we're going to have clinical trials. So we'll test our wonder nutrient on animals first, and then we'll test to see if it's safe on humans. And then we'll test to see, does this product actually do what we think it's supposed to do? All right, so that's going to require a very small population of volunteers typically, make sure it's safe on humans, make sure it actually has an effect on their weight loss. And then we can start a larger clinical trial where we'll try to do it on a much larger population and see again if it's actually effective. We get all that data, we analyze that data. And if it's safe and if it does what it's supposed to do, and if it's a relatively new or different kind of thing than something already on the market, chances are we can get FDA approval and then release that to the general population as an option for weight loss. Another option would be to not have clinical trials, but rather an epidemiological study. So in this case, we're just looking at patterns in the population that are already there. We're just drawing conclusions from data that's already been collected. So for example, we might look at the weight of the general population. We might look at the weight of subgroups in that general population. We might compare that to their eating habits. We might draw the conclusion populations that eat more fish are generally have lower cholesterol or something like that. So we're comparing cholesterol levels that are already known, the amount of fish we're eating that's already known, and we're comparing those two numbers to see if there's a connection. And then we're analyzing that data and drawing some conclusion from it. So that's the gist of chapter 1. Thank you for watching.